Welcome to Brain Vision.
Gears. One of them, or two of them, have mass 0.675 kgs. One of them has a mass of 3.6 kgs. Ka and Kb, the radius of gyrations, are 0.040 meters. The mass, the moments, and Kc is 0.100 meters. The moments A and B are 0.15 Newton meters. And our moment C is 0.3 Newton meters. We have a initial angular velocity of 2,000 RPM, which we're going to multiply by 2 pi over 60 to get our conversion to radians per second. So that's 209.44 radians per second. And finally, our final angular velocity is 0 since it's coming to rest. Now we are asked to determine the time required for this to come to rest. So what we're using in this situation is the net impulse provided to the system. The impulse is equal to the change in angular momentum. In this case, our final angular momentum is 0. So we only have I of the system times the angular velocity of the gear. So we are going to take our impulses. Our impulses are going to be 0.15 plus 0.15 plus 0.3 times t, and it's going to be Ka squared plus Kb squared plus Kc squared, all times the mass of, that's not correct, because we have Ma times Ka squared plus Mb times Kb squared plus MC Kc squared, and that is the total moment of inertia of the system. We're adding together all of the individual moments of inertia, and we're multiplying that by the angular velocity. So our t value is going to be, we're going to simplify this a little because these two are the same thing. So we have 2 MAKA squared plus MCKC squared times omega all over 0.6. That's going to be t is equal to 2 times 0.675 times 0.04 squared plus 3.6 times 0.1 squared times omega, which is 209.44, all over 0.6. And that will give us a time of 0.6 13.3 seconds.